Alright, so this is going to be the video for learning target number 6. Now, learning target number 6 on your note packet is different than the learning target 6 notes that I have here, that I gave you. Okay, we kind of changed the target, but we forgot to change it on the actual note packet itself. So just disregard what the note packet says and what's in the note packet, because we just felt like this is closer to what we needed to do. Now, I'm on the back of your notes page right now. It should look like this. Okay, the hole should be on the right. Okay, now the target here that I'm going to ask you to be able to do is I'm going to ask you to recognize ordered pairs that match a specific linear equation. Now, I'm sure there's a lot of words that you probably really don't understand, like specifically this one right here. You guys don't really understand what a linear equation is yet. It's something you're going to go into more depth a little bit next year, but really in 8th grade you're going to really get into it. And then this is a big important component to algebra. I mean, it's really what algebra is all about for the most part. So I'm going to start here. Okay, this is a linear equation. Okay, a linear equation, it's going to create a line. Okay, so you see the word line in there, that's the root word. Okay, so like I said, I'm going to jump back and forth from front to back of your page, so just kind of bear with me. But basically, you know that when you have a coordinate plane, okay, you know that the horizontal axis, that one, that is representing x values, and the vertical axis, that's representing y values. And when you plot a point, like let's say 3, 5, something like that, you know that you start here at the origin. Remember, you have to go left or right first, so remember you have to walk to the elevator before you can go up or down the elevator in the hospital, or Superman runs before he flies. Okay, so if I have to go to 3, so let's just assume that 3 is right there. Okay, and then I'll just kind of number this. This doesn't have to be perfect. I'm just doing a little refresher here. I know that if I go over 3, up 5, that's how I find that out. Okay, now this is just a point to you guys, but this actually could be made into a linear equation if you had more than one point, which is way above 6th grade, so that's not the point of this. But basically what you can start having, and now I'm going to flip back to the front for you guys, okay, is this question. Okay, now I just want to take a moment to kind of look at it. First off, this was on your review sheet number 26, so it should look familiar. Now, you didn't have this question down here with it, but regardless, this is a line. As you can see the line right there. There it is. Okay, there is a specific linear equation, so it's going to look something like the other side looked. Okay, so whatever it was, that one on the other side was 2x plus 5. And basically, it's an equation, but instead of saying what y equals, we're just saying x is something, y is something. Okay, and it can change, and that's how you get your line, which, like I said, actually making the line and really understanding what the line means is more going to be concentrated in 7th and 8th and 9th grade and so on. Okay, that's not really the purpose of what we're doing here today. Okay, what we're doing here for this target is you guys are going to have to, let me go back, you're going to have to just understand that right there, that particular linear equation, it's a line. Okay, I could do it for you, but that's not even the point. But that creates some sort of line, because every x is going to have a y that goes with it, and that makes a coordinate. Okay, which is probably really confusing to all of you. All you really have to do on this is you have to take these coordinates, and you really just have to plug them in. Okay, so what I mean by that is, let's look at A for a moment. Okay, we got to remember that whenever we have a coordinate, it goes x, comma y. Okay, that's how the coordinates go. That's why when we talked about Superman running before he flies, this is your x. Okay, that's the one that determines left or right and by how many. The y is your up and down. Okay, the vertical, which determines how high, either up or down, and then how far up or down. Okay. Okay, so what you really have to do here is you have to just determine if these ordered pairs will fall on this particular line. So really it's just a plugging in kind of exercise. That's really all we're doing on this. Okay, and that's really the whole point to this. Okay, for now anyway. At least I want you to understand that, you know, like for instance, if I took a line here if I had this and I just made this through here, just understand that that line right there, that has some sort of linear equation that would look like this. It just might not be y equals 2x plus 5. Okay, it's going to be something else. So that's, I guess, what I'm trying to just show you guys, which is one of those kind of challenging things to teach because you don't know that much about what this really means. Therefore, it's kind of hard to teach it. But regardless. Okay, so we have letter A. So what I'm going to do is I'm going to zoom in here. I'm not going to go back. I'm going to zoom in. There we go. Now I'm just going to kind of line this up as A, B, C, and D. So first, for A, what we're going to do is we're going to take this x value, because remember it goes x comma y. We're going to plug it in there, and then we're just going to see if when we evaluate 2x plus 5, it better give us y. Because if it doesn't give us 4 here, then we've done something wrong. So we're going to take this and we're going to say, okay, I'm just going to plug it in. 2 times 2 plus 5. Of course, you have to follow PEMDAS. All the same rules apply there. Okay, so here we go. That's going to be 4. And then 4 plus 5 would give us 9. Okay, so would this be an ordered pair that falls on this line? No, it would not. Now let's understand something right now. I want to make sure we do understand this. If I look at 2, I'm saying that's my x, and because the 2 times 2 plus 5 gives me my y, that means that this is my y. So right away, based on what I just did right here, by plugging in the x value 2, what I'm finding is that I know that the point 29 is absolutely a point on this particular line because that x resulted in that y. Okay? Which tells me right away that without doing any more work, I already know that letter D is done. So I can go ahead and just put D, and that's my work for it, proving it. Okay? All right, now let's go to letter B. We've eliminated A, and we've already said D has to be one of the answers. Let's go to letter B. So we're going to do the same thing. We're going to take the x value that's given. We're going to plug it in. So we know that's going to be 2 times 1 plus 5. Now, keep in mind, in order for this to be true, this thing right here has to equal 0 because that's the point we're asking. We're asking about the point 1, 0, and if that makes it true. Okay, so we do that. We do multiplication first. 2 plus 5 gives me 7. So, do you think B is going to be a give you an actual answer here? Or is this going to be a coordinate that's going to fall on this particular line? No, it's not. No chance. But what I can tell you is, do you know what point would work here? Do you agree that 1 comma 7 works? Okay. Do you agree with that? Hopefully you're all nodding your head yes. Because think about it. If you plug in a 1 there and you evaluate that and you get a y, then yeah, that y right there, this is your x, this is your y, that y has to be a coordinate to that particular linear equation. So we eliminated B. Now let's go to C. We're going to do the same thing. We're going to plug in 4 now. We're going to plug in our x value, 2 times 4 plus 5. So we're going to go ahead and do 8 plus 5. Whoops, what am I doing? 8 plus 5, that's going to give me 13. So once again, this would have to give you the point 44. It didn't. It gave us, we used the x value of 4. We used the y value of 13. So we know that this is a coordinate, this is a coordinate, this is a coordinate, this is a coordinate that falls on that line, but 4 itself is not a coordinate. Okay? So hopefully that's making sense. All right, I would like you guys to, I want the video to be paused, and I would like you guys to try, number 2 here. The only thing here is that you need to know is we want to know which one does not fall. So remember, this is a line. It doesn't matter really what that line looks like. And if you knew how to graph that line, you could just graph it and then figure out if those points are on the line or not. But you don't know how to do that, so you've got to use the other skill, the one we just went over. So I'm going to go ahead and pause this and try it. Okay? Hopefully you've paused this already and done it. You better have. Okay? So we're going to take the x value. So we take that 0, and we're just going to plug in the 0. And if this doesn't give us -1, then we've done something wrong. Okay, that's the whole point of this. Then we know it's not a coordinate. So I look here and I say, okay, I'm going to go ahead and plug in 0. So 3 times 0 minus 1. Okay, 3 times 0 is 0. 0 minus 1 would give you -1, right? You have 0. If you take away 1, you have -1 now. Okay? So right away, I'm looking at this and I'm going, okay. That means that based on this particular x value, so this, I did not go left or right at all. I just stayed at the, I didn't go left or right at all. I just stayed right at the origin. And this was the y that it gave me. So that means that the point 0, -1 would absolutely be a coordinate on this particular line. So I know that this would be a true. This would be true. Remember, we're looking for the one that is false, essentially. We want to know which one does not fall on the line. That one is true, so that would not be the answer. Okay, let's go on to letter B now. Okay, so we have, once again, we're going to plug in our x value, which is always this one, and we're going to see if this is this. That's the whole point of this. So we got 3x minus 1. Whoops, I didn't want to write that. Sorry if you already wrote it. 3 times 1 minus 1. So we're going to go ahead and do 3 times 1 is 3. 3 minus 1 would give us 2. So right away, we know that the point 1, because that's my x, right? And the point 2, which is my y, that has to be a coordinate on this line. This linear equation would have this as a point, as an ordered pair. So once again, that's what it says here. So once again, that would be true. So it would not be B. Okay, letter C. Okay, I know that the point is 2, 6, so I have to zoom out a little bit here. I know that's going to be 3 times 2 minus 1. So I just plugged in my x again. I'm going to do that. That's 6 minus 1 is going to give me 5. So right away, I know based on this inequality, I plug in a certain x value. This is the y that it gave me. So I know that the coordinate 2, 5 is a coordinate on this line, which means that this right here is false. Okay? Now remember, you should never just be content. I always tell you guys, find all 3 wrong answers. Don't always just find the right answer, and it will lead you to success. I should see 3 wrongs, not just 1 right circle. That's the way we've always done it. So now let's do D real quick. We know that we're going to plug in 3 for x because of the x value 3. 3 times 3 minus 1, we're going to get 9, and then 9 minus 1 is going to give us 8. So we know that the point 3, 8 is a coordinate or an ordered pair on this line, which makes this true and eliminates it. Therefore, we're down to letter C. Okay? Hopefully this is making sense. It's a lot of new words and it looks all fancy and difficult, but what we're doing, what we're trying to accomplish is not that challenging. Okay, we'll do one more here. Okay, I'm actually going to go back to go back to the front here. Okay, now here, what we have going on is you got to figure out what's happening to the x. Okay, so you would really, what you can do is you know all these coordinates fall directly onto the line, every one of them, because it says it. So basically, you know that this is an x. Let me take that off a little bit. It's too wide. You know that this is an x, this is a y. This is an x, this is a y. This is an x, this is a y. So basically, you got to take these, plug them into all of these equations, these linear equations, and see which one gives you the other. So you plug in your x. So what I'm going to do is I'm going to take this and I'm going to say, okay, what is 3 times 6? Because that's my x right there. And that's going to be 18. So is that the y that's given? Is that going to be, is right there going to be 6, 18? Because that's what the coordinate would be. No. Okay, plug in the next x. So we're going to take our x right there, we're going to plug it in here. So 6 minus 3 is 3. So is that right? Is the coordinate going to be 6, 3 or 6, 2? It's got to be 6, 2 because that's what it says right there. 6, 3 would not fall on this line. So we eliminate B. Letter C. Now we have 1/3 times 6. Okay, so you may have to do a little work here. But regardless, you do top times top, bottom times bottom. You're going to get 6 over 3, which simplifies to 2. Okay, so what we're saying is that when you do y equals 1/3 x, and you plug in 1/3 times 6, it will give you the y value of 2. So right there we know that the 0.62 absolutely makes that true. Okay. Now just to prove letter D, because again I like to always find the 3 wrong answers, not just the 1 right answer. We'll go ahead and plug in 6 here. Well, if we did the x6, and again I'm getting that from that, plus 3, wouldn't that give us 9? So that point is certainly not 6, 9. We just eliminated letter D. Okay. We seeing how to do this now? I hope you just kind of plug it in and going there. Okay. And then this, we can talk about this actually. There's a lot of different ways you could do this, but if we want to know how many teaspoons would have dropped at 21 minutes, there's several different ways you could do it. The one way is if this graph were just a little larger. I mean, think about it. We put an arrow at the end of these lines for a reason, because they'll go on forever. If we kept this graph going here and actually kept it going that way, and we kept it numbering 20, 22, 24, it's not going to be right if I try to do it that way. But if it actually had a grid, you could go all the way over to 21 minutes, which would be somewhere over here, and then just go up to the line and say, oh, right there. Now, I'm not saying that's the answer, because it's not accurate with the way I did it, because it's got to be the same size. But if it was like that, you could use that method. But what I'm trying to get you to see is, if you know that this right here is your linear equation, and you know the minutes right here is your x value, can't you just take 21 and plug it in for x and just do 1/3, 1/3 times 21, and obviously 21 over 1, you end up getting 21 over 3, which would be 7, okay, which means that is your y. So that means on that line up there, we know that the point 21, 7 would have to be a coordinate. And that would say that, okay, if I went over to 21, let's just assume 21 was right there, and then I went up to 7, don't you agree that that line would probably pass right through that point? Because that would be 7 right there, right? 7. And 21 would be about right there. You see what I'm trying to do there? Okay, so that's how you do it. Or the other way you could always do one like this is you could always do the upper portion, like using this as the fake ratio right there. So you know that there, for every 6 minutes that water is dripping, there are going to be 2 teaspoons. And then you just put in 21 minutes, and then you guys could do it from there and get 7. Okay? But really, we're really trying to stress this algebraic equations and really understanding that every linear equation, every linear equation is going to have several things that make it true. An x value that makes it true, and then that x is going to result in that y. Okay? You guys have probably talked about in science the independent and dependent variable. That all ties into the same thing. So, you definitely got to understand that. Okay? All right, go ahead and flip to the other side again. Okay. Now on this one is a little different because you're going to be creating a table. Okay? So a lot of times the tables will be given for you, but I just wanted you to kind of create one on this. So let's just start with a rectangle, I guess. And these can be done both vertically and horizontally. Okay? I don't know how many. Let me see how many rows I think I need here. One of these, this is going to be your x, y, so your coordinates. Okay? This is going to be your x, and then this would be your y. And just remember, you get this from doing 1/2 x plus 1. Okay? So this will make sense in a minute. Go ahead and do that. And we will just do 1, 2, what is that? 4 rows. Okay? Now, basically, we already had one like this on a review sheet. I don't remember which review sheet it was, but you guys had the x's were given. I don't know if it was like 1, 2, and 3, something like that. And then you had to basically plug in that in there to get you your y. So you have to take this and say, okay, I just got to plug it into that to figure out y. I got to take this, plug it into that, figure out what y is. Okay, so that's what we're going to do now. So and it doesn't matter what you picked as your x's. It doesn't matter. You could have picked 10, 200, and 5,000 if you wanted to, but that would be kind of ridiculous. You always want to pick numbers that you can graph and we're going to graph here in a minute. So I'm just going to do 1, 2, and 3. It's an easy graph to make. Could have done 2, 4, and 6. You know, 1. I mean, you could have done any numbers at all. So now I'm going to take that and I'm going to plug it in. Okay, you may have to do your work somewhere else. So I'm going to do 1/2. Okay, that's just that. Now it says times x. Now if my x is 1, I'm going to go ahead and just do 1. Now I'm going to go ahead and write it as 1/1 for now, just because I know that's going to have to happen anyway. And then I can add 1. So I know that any number times 1 is already going to be itself. I guess I didn't have to make it a fraction, but I think we all got that. And then you do 1/2 times 1. Well, that's going to give you 1/2. But I want you guys to always avoid mixed numbers. So let's write it as 3/2. Okay? But it's good to know both and understand, because I know this one here really has meaning. You really understand that that's 1 and then halfway to 2. This one, you don't really understand that yet, but regardless, either one's right for this year, but your teachers in 7th and 8th grade are going to want you to use improper fractions. Okay, and that was that one. Now we got to show our work for the x value too. So we'll do 1/2 times 2. I'm going to go ahead and do 2/1 plus 1. So I'm going to do multiplication first. That's going to be 1, because you know those are reciprocals of each other, and we know that reciprocals are numbers that are the only type of number that can multiply to get 1 are reciprocals of one another. Then I'm going to do 1 plus 1, and that's going to give me 2. So that means that my y is 2. Okay, so I'm just taking the x value, I'm plugging it into my linear equation to get me my y. Okay, and then finally I'm going to do 3. So I'll do 1/2 times 3. Again, I'm going to do 3/2 there, or 3/1 plus 1. And when I multiply top times top, bottom times bottom, I'm going to get 3/2, which you guys should know is same as 1/2. And I'm going to end up getting 2/2 or 5/2. So I'm going to put both those on there. It's not a bad idea to have both. Okay? So, and like I said, you could have used 2, 4, 6, you know, whatever. It doesn't matter, because you're going to see when I draw this. Now, do your best to draw your number line fairly accurately here. So I'm looking at this and I'm going, okay, I'm able to make a straight line with my little tool that I have there. You really don't have that option, but just do your best. Make it neat enough to where you can read it. You always label your x and your y too. Always. Whenever you make a coordinate plane, you always label your x and your y. Okay. Now, based on what I'm seeing here, I'm just going to try to make them spaced out enough. I could number all the way if I wanted to, but I'm just going to number to 4, because that's all the farther I need to go. Do the same thing going up. So 1, actually that's on the wrong side. I like it when it's over here. 2, and then 3, and then let me extend that just a little bit. There we go. Okay, so then I'm going to go ahead and make it go to 4. Okay, now from here, and you should really number negatives, but since we haven't done too many negatives this year, it'll be more of next year in 8th grade, you can skip that part, but I'll put them on here just so you know they're there. We just won't be using them for this. So now, I forgot to finish my table here. I know that I could have plugged anything in I could plug 10 in there, and it would give me a y. Okay, it would give me 6. Okay, because 1/2 times 10 would give me 5. 5 plus 1 is 6. So, you know, you could have done any numbers, but what you're saying is your coordinate is 1 and then 3/2. That's your coordinate. You know that is absolutely an ordered pair that goes with this particular linear equation. Okay, here we got the point 2, 2. Okay, so if you plug an x to that's 2, you're going to get the 2 back out. Okay, and finally you got 3 and then 5/2. Okay, and then if you did 10, which you didn't have to, you would get 10/6. Okay, you could go on and on for days. I mean, you could put decimals in here, fractions, all kinds of different things, and you would get a different y value out. Okay, so we're going to go ahead and plot these points. So first of all, we plot 1, and then I know that is 3/2. So that's going to be over 1 up 1.5 right there. Okay, then I'm going to go over 2 up 2. And then I'm going to go over 3, up 2.5. You can see that this is making a nice line, okay, that I can connect here. If I can do this without, see, it's not perfect, but that's part of the problem with trying to do it without grids. It's either really hard to make without grids. These should all be on the line, and I wish I would have just put a little grid right here to really help myself, but that almost looks like 3. That was probably a little bit too high. I could probably redo that. Let me redo 1 point. So that's 3 and then 2.5, so 3 and then about right there. I think that's more accurate. Okay, and then if I'm doing this, it should match a little better. There we go, that's better. So you can see they all fall right on that line. And guys, I mean, if I extend this out to 10.6, if I actually took the time to do this, I mean, you can guess where 10 would be. 5, 6, 7, 8, 9, 10. Okay, and then if you went up here like this, you would have 5 would be here, 6 would be here. I can tell you that somewhere around in here, like right in here, this point should extend through that point as well. Okay, now again, because it's not spaced correctly and all that, it's going to be a little off, but that's the point. A linear equation is going to have an infinite amount of ordered pairs. Okay, and if it falls on that line, it will have that x will make that y. Okay, so whatever it is. So that's basically what you're looking at here. So I'm going to let you guys go ahead and get started on the rest of this little packet now. Okay, it's 6 pages. Just do as much as you can. It's not overly difficult, I don't believe. It's the same stuff we just talked about. So just start working on that. This stuff will be on the test. The substitute will have the answer keys. So hopefully this helped, and you're not too confused. But we'll get you where you need to be if you are.